Welcome. In this video, we're going to compute several limits. That is, we're going to compute the limit of f of x as x approaches infinity, as x approaches negative infinity, and as we approach 6 from both the left and from the right. Then we're going to use these limits as well as the roots to manually sketch some rough version of f of x. So let's begin. The limit as x approaches infinity of x plus 6 over x squared minus 36 is equal to the limit as x approaches infinity of x plus 6 over x plus 6, x minus 6. Since I have a factor of x plus 6 and x minus 6 in the denominator, I can rewrite this as the limit as x approaches infinity of 1 over x minus 6. Now before I finish this, we can already see that as x gets larger and larger, the denominator is going to get larger and larger, which means this entire fraction is going to get smaller and smaller, since as the denominator of a fraction gets larger, the fraction itself gets smaller. This tells me that this whole limit is equal to 0, but before I write that down, I want to quickly verify something. Are my values as x gets larger and larger getting to 0 from above the x-axis, that is positive values, or from negative values? So let's try a few. Let's try 10, let's try 106, and let's try 1006. So this is 1 over 4, or 0.25. This next one simplifies to 1 over 100, or 0.01. This next one simplifies to 1 over 1000, which is 0.001. So as I can see, I'm getting closer and closer to 0, but I'm doing so from positive values. So let's keep that in mind. Okay, now let's evaluate the limit as x approaches negative infinity of this same function. And to save space, I'm going to jump straight to this step here, since I can write x plus 6 over x squared minus 36, but we all know that I'm going to get to the limit as x approaches negative infinity of 1 over x minus 6. So I'm going to skip this busy work in the middle and just go ahead and write 1 over x minus 6. And now I know this is also going to approach 0, but now I want to double check, am I approaching 0 from above or below the x-axis? Since we've already confirmed we're coming in from above y equals 0. So rather than looking at positive 10, positive 106, and positive 1006, I'm going to look at these as negative values, since I know x is getting more and more and more negative. So this first value is going to give us negative 1 over 16, which is negative 0.0625. Next, I end up with negative 1 over 100, which is negative 0.01. And finally, I end up with negative 1 over 1000, which is negative 0.001. So this tells me that I am approaching 0, but I am approaching it from below the x-axis. All right, so this limit is done, this limit is done. Now let's evaluate the limit as we approach 6 from the left. So the limit as x approaches 6 from the left, and again, I'm going to skip straight from this algebraic step to this one. So as I get closer and closer to 6, I'm going to get a 0 in my denominator. So let's look at a table. So here's x, and here's 1 over x minus 6. And we're approaching from the left. So we're approaching from values of 6 that are smaller than 6. So let's say 3, 4, and 5. This one would give me 1 over negative 3, or negative 0.33. Here I end up with 1 over negative 2, or negative 0.5. And here I end up with 1 over negative 1, which is just negative 1. Let's try some values even closer. What if we try 5.5 and 5.00 and 5.9? So in this case, we end up with a negative 1/2 in our denominator, so a negative 2 in our numerator. Here we end up with 1 over negative 0.1 in our numerator, so that's negative 10. And I'm going to try one more value just to illustrate my point, and I want you to do this one independently. Please try 5.999. What do you end up with here? 1 over what? You should end up with a negative 0.999. 0.001 in your denominator. And this simplifies to negative 1,000. So what we can gather from this table is that as x values approach 6 from the left-hand side, the values of f of x are getting more and more negative. That is, they're getting very large negative. So this is negative infinity. We can do the same thing for the limit as x approaches 6 from the right of 1 over x minus 6. So now we're approaching 6 from this direction. And so I'm going to leave it to you to try 6.5, 6.1, 6.001. You should have gotten these values 2, 10, and 1,000. So as the x values approach 6 from the right, our function is getting more and more positive. That is, it's growing without bounds. So that's infinity. So now let's consider the removable discontinuity. As you recall, one of the first steps I did in this first limit was to rewrite the denominator as x plus 6, x minus 6. This left us with 1 over x minus 6. And that tells me that for x plus 6, when this equals 0, we know x equals negative 6. So we have a removable discontinuity at x equals negative 6. In other words, there is a hole in the graph. Finally, we need to ask ourselves if there are any roots, that is, any spots where this function will intersect the x-axis. And already looking at this, I can see that there's not. Because recall, in order for a function to intersect the x-axis, we have to find out when this function is equal to 0. So this is equivalent to finding out when 1 over x minus 6 will equal to 0, which will never happen. The only possible way for this, or any fraction, to equal 0 is to have a 0 in the numerator, which will not happen since the numerator is fixed at 1. Only the denominator varies, and we definitely cannot have a 0 in the denominator. All right, so using that, let's sketch a graph. So as you can see here, I went ahead and sketched out an axis. Here's x, here's y, and I also listed out the facts that we've already covered about this function. And as a reminder, this function is f of x is equal to x plus 6 divided by x squared minus 36. We know that as x approaches larger and larger values, our function will approach 0. And we figured out that this was from above y equals 0. So I'm going to go ahead and pencil that in. We also know that as x approaches more and more negative values, that is, we travel in this direction along the x-axis, the function f approaches 0, and that's from below y equals 0. So there is that portion penciled in. Additionally, we figured out that as we approach 6 from the left, so that is, x is approaching 6 from the left side, the function f of x will continue to get more and more negative. So here's that part penciled in. We also figured out that if we approach 6 from the right-hand side, f will get more and more positive. Finally, there's a removable discontinuity at x equals negative 6. Okay, so now I can connect these dots, and I'm going to do so in red. And now the last thing left to do is to demonstrate where the removable discontinuity is, which is here, so that's a hole. And then, for good measure, I'm going to sketch out our vertical asymptote, which is here at x equals 6. This function also has a horizontal asymptote. This function also has a horizontal asymptote here at y equals 0, which is the x-axis. I hope this video was helpful.